So this is our problem set number 2 for the torque. A man who weighs 800 Newton climbs to the top of a 6-meter ladder that is leaning against a smooth, frictionless wall at an angle of 60 degrees, with the horizontal as sketched in the figure below. The non-uniform ladder weighs 400 Newton and its center of gravity is 2 meters from the foot of the ladder. What is the force exerted by the wall? Basically, the first given is the weight of a man, which is 800 Newton, wherein the distance from the pivot is 6 meters. And the weight of the ladder is 400 Newton, and the center of gravity is within 2 meter coming from the ladder. So that's 2 meters from the foot of the ladder. And given an angle which is 60 degree. The required is the force coming from the wall. So there's the force. And equation would be torque is equivalent to force perpendicular multiplied to the distance from the pivot. Or simply torque is equal to sine theta multiplied to force to get the perpendicular force and then times the R. Our solution, we simply state since this is not moving, the sum of all torque is 0. But the sum of all the torque, we have the weight of the man multiplied to the R or the distance of the man from to the pivot. Another component. So if we want to look if it will become positive or negative, we definitely look from the pivot. So this will be our pivot. And we all know since 800 Newton, it will turn into counterclockwise. So therefore, it is positive. That would make us a positive sign. And the ladder's weight, there you have your 400 Newton multiplied to R. Will it become positive or negative? Since it will turn counterclockwise, that will still be positive. And therefore, another component, force that's being pushed by the wall multiplied to R, and the direction is clockwise direction. So that is negative. And that's it. Now, let's try to redraw the illustration. Okay. So you can see this is the force going down, which is the 400 Newton. And it will form a right triangle. And we have the angle which is equivalent to 60 degree. And the other angle that we have is 90 minus the angle. Basically, the sum of these two angles is 90. So let's try to make it clear. So we have the angle there, and then the 90 minus theta. And then this one, we define it, we want to find the perpendicular force. So we have the 400 Newton. So here's the perpendicular force coming from the ladder. And this one, since this is 90 minus theta, this one is the opposite side. And then the other one, we have 800 Newton as the weight of the man. And then we have this angle. It is also 90 minus theta. Okay. And this angle And this angle, as we could see, we could expect that they are alternate interior angles. And we all know that in our geometry class, alternate interior angles are simply congruent. Now, with respect to this angle, we could see that this one is the opposite side. So therefore, we could now use our sine function. So, the weight of the man multiplied to r, or the distance from the pivot, is force coming from that man, which is sine 90 minus theta, multiplied to distance. So if we're talking about the ladder's weight, that is ladder's weight multiplied to sine 90 minus theta multiplied to the pivot. And the other component, we have the force coming from the wall. We simply have force of that wall, that is sine theta, because we all know this is the opposite side, multiplied to the distance from the pivot. So we could have copy the sign, positive, and then positive for the weight of the ladder. And then since the other is different, it will turn differently, which is in clockwise direction, that is negative. So we could now have this formula. That will be our general formula. And we can simply plug in all the other values. Since that ladder is not moving, we could expect that the sum of the torque is 0. So we have the positive. The weight of the man is 800 Newton, sine 90 minus 60, and then 6 meter. Now, we have alternate value for sine 90 minus 60, and that is cosine of 60. And once you press your calculator, sine 90 minus 60 is just equivalent to cosine 60 degree. Plus 400 Newton sine 90 minus 60 multiplied to 2 meters, that is the distance from the pivot. And then F wall, to the force coming from the wall, which is we don't know, multiplied to sine 60 multiplied to 6 meter. And then we do the math thing. So let's calculate first. Okay, and 90 minus 60, that is 30, sine 30, that's equivalent to 0.5, and then therefore we could get 0.5. Okay, so 0.5 times 800 times 6 meter. We could do the math thing, but remember this one is F wall, so we don't have values for this. So we simply transfer it to the other side. So from negative, that would become positive. And 800 times sine 30 times 6, that's simply 2,400 Newton meter, plus 400 times sine 30 times 2 meter. We have 400 Newton meter. And pressing in calculator sine 60 times 6 meter, that would become 5.196 meter, multiplied to F wall. And 2,400 Newton meter plus 400 Newton meter, that's 2,800 Newton meter. So we have the F walls equals to 5.196. So we have 2,800 Newton meter. Divide both sides by 5.196, 5.916. Cancel the meter. Cancel the meter. And then therefore 2,800 divided by 5.196. The force coming from the wall is positive 5 to the 8.876 Newton. Our answer would be 500 Newton for one significant figure.